Good morning, everyone. Welcome to my channel. And for today's video, I will be discussing PCSP 423 computer software in structural analysis. No, so introduction to different software and used in design analysis of a structure tayo. So this will be the topic one and week one topic one of our subject, which is the PCSP 423. And last video, I discuss or I orient my students with regards to sa syllabus content and also the content of topics to be discussed within this whole semester for this subject. No? And for today, I will be discussing introduction to different software used in design analysis of a structure. So first is ano muna tayo, konting introduction muna, no? Bago tayo mag-proceed dun sa actual na paggawa ng or pag manipulate dun sa software. Okay? So first, let's define structural analysis. Structural analysis is the method of determining and calculating the effects of loads and internal forces acting on the structure, buildings, or objects. It is a process determining the response of the structure to specified arbitrary external loads. So si structural analysis is yun yung ginagawa natin sa ating mga major subjects like theory of structures, yung kinukompute natin yung mga reactions sa support, kinukompute natin yung mga shearing stresses na nangyayari as well as yung bending, as well as yung mga deflection. No? We always double check kung pasok siya sa minimum standards. No? Kasi pag nag-exceed dyan sa minimum standard, ibig sabihin, mag-fail yung natin design. So yung structural analysis is a method of determining and calculating the effect ng mga loads na na-apply natin o internally and externally dun sa ating structure, no? Kaya anong sinabi ko kanina, yung theory of structure, no, na kung saan ay kung halimbawa meron tayong building, no, na may syempre yung weight ng building is considered as dead load. Yung weight ng mga tao na mag-occupy dun sa building is considered as live load. Yung mga machines na ilalagay ninyo, kung halimbawa yan ay mga hospital na kailangan may machines or may mga government healthcare center or yan ay commercial building. So, kailangan nyo i-consider yung lahat ng mga possible weights na i-carry ng building. As well as yung mga earthquake load. So, yun. Then, after mo ma-apply yung mga loads, i-check mo kung ano yung magiging effect dun sa structure niya. Kaya nga, yun yung ibig sabihin ng structural analysis. No? Okay, let's proceed to the importance of structural analysis. Structural analysis of structure is essential before starting construction work. It provides the detail of the size of the foundation, the size of the column and beams, and reinforcement details that are sufficient to carry the loads acting on the structure. Before constructing any structure, there are several documents required like plans, elevations, and section details. This process of finding out the loads that a structure can carry safely without failure is called structural analysis. So, yun nga. It is important na kailangan muna natin magkaroon ng structural analysis bago tayo mag-implement ng construction. Mag-implement or implement yung project natin. So, bago tayo mag-start ng kailangan na-check na natin or nagawa na natin ng well-design yung structure. Kaya nga, yung structural analysis, tayo yung naglalagay kung ilang kadaming bakal yung gagamitin, kung anong size ng bakal, as well as yung columns, yung beams, anong size nun, gaano kalalim yung pundasyon, based dun sa mga loads na na-consider natin and na i-apply natin dun sa ating structure na consider to conduct structural analysis. No? And ito yung mga kahalagahan niya. First is to know the behavior of the structure under the load condition. So, kailangan natin ma-identify kung ano yung magiging behavior or effect ng ating structure pagdating sa mga loads na na-apply natin. Then, to know the maximum loads up to which the structure can be loaded so that the structure will not fail. So, yun. Kailangan din natin ma-check for minimum standards for deflection, for shearing, and for bending yung ating structure. Kasi, kailangan natin ma-identify yung maximum loads na kaya niya i-carry. Kasi baka mamaya, mag-exceed yung mga loads na natin na ilalagay or nagkamali tayo din sa mga loads na nilagay natin, di natin anticipate yung ibang loads. So, possible, kapag nagdagdag yung owner ng mga equipment or nadagdagan yung loads, possible na mag-fail yung ating design, no? Next is to ensure that the displacement and deformation remains in permissible limits. Yun yan, sabi ko kanina, yung deflection. So yun, may mga minimum deflection tayo in structure na kung saan ay kailangan natin i-consider kapag tayo ay nagde-design. Okay? Next is basic concepts on structural analysis. First is the idealization structure, threats on structure, calculating the response of structure under the threats, and calculations of internal stresses. Dito naman, kumbaga, ini-explain lang dito yung basic concepts ng structural analysis. Kumbaga, kapag manual computation yung structural analysis natin, ganito yung magiging natin. First is the idealization of the structure, then identifying the threats of the structures, yung mga loads, no? Then, calculate natin yung response ng structure based sa mga threats natin consider. Then, the calculations for internal stresses, yun yung mga deflection, yung shearing and bending na kailangan natin i-consider. And this naman, sa susunod na slides, naman natin yun, madadaanan. Okay? So, kung baga ngayon pa lang, introduction pa lang naman to. So, kumbaga, dun sa subject na computer software for structural analysis design, no, kumbaga pinapakita ko lang sa inyo kung gaano ka-laborious yung trabaho natin bilang isang civil engineer at bilang isang structural engineer na nagko-compute kayo manual ng kaya nga siguro inilagay sa curriculum na kailangan din maging familiar yung students sa mga software para at least pag lalabas ninyo sa university, pag mag-a-apply na kayo ng trabaho, may knowledge na kayo kung ano gagawin nyo. Kasi ito naman talaga yung gagawin ninyo. Or ito naman talaga yung ginagamit na. Bihira na ngayon yung nagmamanual. Especially kung mga high-rise yung structure natin. So ito nga, yung basic concepts ng structural analysis. First is mag-idealization ka ng structure, then identifying the threats of the structure, then calculating the response of the structure under the threat, and calculations of internal stresses. So, dun sa idealization, yung concept natin sa idealization ay we assume that the beams as a line structure. So, yun nga, yung parang kino-consider natin yung mga beams natin, yung columns, yung lahat ng makikita natin ay puro line lang sa ating structure, no? Kumbaga, parang free body diagram, identify mo lang kung ano yung mga loads, kung ano yung structure mismo, kung ano yung itsura ng structure. Then, the joints of the truss are pin joints. So, yun yung mga consideration natin kapag tayo ay nag-idealize. Then, in truss, we assume loads are acting only on the joints. Loads acting on members cause bending moments which is not suitable for the truss. So, kapag tayo ay nagde-design ng ating bahay na mga structure na may trusses, we assume that the loads are applied on the joints of the trusses, no? So, yun kapag manual, manual computation. But later naman, madidiscuss ko naman kung paano pag sa software siya, no? Then, we assume truss to possess pin or hinge joints. So, the connection of the trusses are either pin or joint connection, no? Or hinge. Then, for threats on structure, dyan sa threats naman, threat on structures are the forces acting on it which lead to reduce its capacity and stability, concentrated load, distributed loads, and moments. So, sa threat of structures naman, in-identify natin kung ano yung mga possible maging weights ng yun nga, yung threat. Kasi yung mga loads na yan, yun yung magkakaroon ng effect dun sa ating structure na gagawin. Kaya nga, we need to consider every loads that are possible to put into the structure that we are always designing, no? For example, dito, meron tayong mga types of loadings dito. We have here this concentrated loads, distributed loads, and moment. Then, meron din tayo tinatawag na medyo maliit natin yung sulat din sa video. Meron tayong tinatawag na vertical loads, horizontal loads, and longitudinal loads. Under vertical loads, yung going down lang yung forces. Kung nakikita niyo itong sa bahay na to, lahat ng pababa, yan yung tinatawag na vertical loads. O either sabihin natin yung vertical loads na yan ay composed of live load, dead load, impact load, no? So kasama na yun dyan. Earthquake load, kasama po dun sa vertical loads. Kapag sinabi namang horizontal loads, we consider wind load, no? Also, horizontal load din ang earthquake kasi usually ang galaw ng lupa is pa ganon, no? For the longitudinal loads, mga moving loads naman yan kapag mga sa bridges naman yan, nagde-design ng bridges kasi usually gumagalaw yung loads natin. No? Kailangan natin consider yung yung magiging longitudinal loads niya. No? Okay. Calculation the response of structure under the threat. So, under naman dito, calculations of reactions, calculations of internal forces, axial shear, and moment, deflection. Dito naman sa part na to, ng pagde-design natin manually, ay dito na, after natin ma-identify lahat ng mga loadings na consider natin, dito ay kailangan natin i-identify kung ano yung magiging effect dun sa ating structure, dun sa beams, kung sa columns, kung ano yung magiging reactions nila, kung ano yung mararamdaman, no? nung ating structure, ng beams at ng column. For example, dito, makikita niyo dito sa mga example na nandito, naka-apply ka na ng weights, then kailangan mo lang i-identify yung mga internal loadings na nag-effect dun sa ating structure, dun sa mga connections na yan, as well as the support reaction and the bending and shearing, no? Stresses na na napoposes or na nararamdaman ng ating structure. Okay? Under naman ng calculation, ito din, kasama din ito doon sa calculations of internal stresses, which is the bending stress, shear stress. Under naman dito, yun nga, kinakalculate na dito yung mga deflections, stresses, like bending and shear. No? Yung mga internal forces na nag-act sa ating structure. Then, yun. After mong ma-identify yun, kailangan mong i-consider, balik tayo dun sa ano. After mo ma-identify lahat ng mga internal stresses na nag-occur dun sa ano, dun ka na makapag-decide kung kapag, yun ay analysis kasi. Kapag design naman, from the standard procedure naman ng ano ng reinforced concrete design, so kailangan mo lang i-identify muna yung mga sukat, no, kung gaano ba kalaki yung dimension ng ano natin ng column, ng beam, and then as well as yung dami ng bakal. So yun yung design analysis kapag design process. Kapag analysis process kasi may mga drawings ka na, i-check mo na lang kung tama yung bilang ng bakal or ng specifications na yun. Okay? Ngayon, ito ay computer software in structural analysis that are widely used by engineers and construction design company. In these slides naman, ipapakita ko sa inyo kung ano yung mga computer software for structural analysis that are used ibang bansa or dito sa Pilipinas. Na ito yung nag-i-aid sa atin bilang isang civil engineer at structural engineer para ma-lessen yung ating trabaho sa pagde-design. Kasi nga, yung pinagdaanan nating slides kanina, yun yung way para mag-design. Then, syempre, in each structure, in each location ng beam, kailangan mo siyang gawa ng design analysis. Pero kung ito ay naka-software na, mabilis na lang siya. No? So, yan. First, we have ETABS. ETABS, Extended 3D, Three-Dimensional Analysis of Building System. It's a software developed by a company called Computers and Structures Incorporated, CSI. It was developed in the year 1990. One of its strongest features is the functionality around the design and analysis and multi-story structures. ETABS used finite element analysis and numerical simulation methods behind the scenes. A firm in Chicago used ETABS to model the world's tallest structure, Burj Khalifa. The seismic response, gravity, and wind loads were calculated using this very software, which is mind-boggling. Now, kumbaga, sa ganda ng Burj Khalifa, sa taas ng Burj Khalifa, na kung saan ay, paano mo siya naisip mo pa lang kung paano siya i-design, di ba? So, one of software that used to design those structures is si ETABS nga. So, kung makikita nyo dyan sa example dyan, may mga figure naman yan. No? So, yan yung itsura ng ETABS. Next is SAP 2000. SAP 2000 is Computer and Structures Incorporated, CSI. Under din siya ng CSI, no? Di ba si ETABS ay CSI din ang gumawa. Ito naman ay CSI din ang gumawa. Also launched SAP 2000 for the analysis and design of structures about 45 years ago. In contrast to the ETABS, this software package is marketed to work with a more general purpose, a civil engineering structural system from basic to advanced configurations, including both 2D and 3D models. This software can be used for accurate design and analysis. Additionally, SAP 2000 also has an excellent module for structural optimization. It is not uncommon to see that it has been used for complex structures such as shells and membranes. Si SAP 2000 is halos pareho lang lahat naman ng structural software ay pare-pareho lang naman ng functions niya to design the ano. Pero ang pinagkaibahan lang ni SAP dun sa ETABS is ito is more complex daw yung mga structures, yung mga dome na ang ginagawa niya, no, yung kumbaga may mga curve na model, no. Okay, then STAAD Pro. Si STAAD Pro is also a structural analysis software that can be used to analyze, design, and model structure in 3D. As it's very flexible, it can model most any type of structure system. Some people claim that it is the most complete software package in the industry. In terms of support materials, STAAD Pro can design structural frames or steel, concrete, cold steel, wood, aluminum used buildings, designs, codes from around the globe. Along with these various conditions can also be applied to explore the behavior and limits of the structural system and at hand. So si STAAD Pro naman is widely used naman kasi ito yung pinaka sikat sa sa lahat. Kung saan ay medyo user friendly din siya na gamitin. At the same time, sabi nga dito, flexible siya gamitin, no? At almost any type of models ay kaya niyang structural analysis, no? Next is, ito is mga another design software na lang din, no? Meron tayong tinatawag na RAPT Structural Engineering Software, RAPT, is a software used for the designing and analysis reinforced and post-tensioned concrete system. An Australian company launched RAPT many years ago to become an everyday tool for practicing structural engineers. Then meron tayong 3B3D, no? 3B3D is a cloud-based structural engineering software for calculating tributary areas, elements, loads, and columns, loads, takedowns. The application includes a comprehensive user interface with visually appealing outputs. Si 3B3D ay alam ko walang bayad to, no, si 3B3D. Parang ano lang siya, computer application or computer application or either parang kumbaga sa cellphone, parang Minecraft, no, na kung saan ay ano lang siya. Yun, parang ganun yung interface niya na kung saan ay libre din tong 3B3D. Then, meron din tayong tinatawag na RAM Concept. Si RAM Concept is a software with a focus on the design and analysis of concrete slabs. One of the software main selling point is that it can design concrete slabs in a very economical and efficient manner compared to the other system. Above all, it designs floors, system, and foundations slab for the focus of reliability and practicality. Then, meron tayong tinatawag ng MicroStran Structural Engineering Software. MicroStran is a general-purpose structural analysis software that has built-in modules for design of steel members and connection details. Using the software modeling commands, it is capable of building structure with an impressive speed. Then, meron din tayong tinatawag na Strand 7. Strand 7 utilizes a Group 3 tool to organize and simply complex models. As a result, you can quickly build and assess models with comprehensive tools in the package. In Strand 7, you can open multiple models simultaneously and shift elements from one model to another. Then, si Space Gas. Space Gas is also 3D and multi-purpose structural analysis and design software used for structural design professionals around the globe. A wide range of features is available in this package for efficient design of structural members such as beams and columns. You can design trusses of a wide variety without too much hassle. So, yun po yung introduction natin pagdating sa pagde-design, no? Ngayon naman, let's discuss one of the software na kung saan ay gagamitin natin para dito sa subject na to. So we have STAAD Pro Fundamentals Part 1, no? So in this Part 1 discussion, I will be discussing hardware requirements and also content of STAAD Pro, no? Okay, so First, hardware requirements. Ibig sabihin lang naman itong mga nakalagay dito, PC with Intel Pentium or equivalent, graphic cards, blah blah blah, operating system, sufficient multimedia. Nakuha ko lang yan dun sa, alam ko, siya latest version ng STAAD Pro pa na hardware requirements. Pero ang ibig sabihin lang po nitong hardware requirements, kailangan mo ng isang laptop na medyo mataas yung specifications niya, no, yung mataas yung graphics and processor niya para at least kapag gumagawa ka ng modeling, hindi siya maglalag, no? So yun lang naman yung ibig sabihin ng hardware requirements dyan, yung 120 MP RAM or higher. Operating system is yan, yung Windows 2000 XP or latest Windows is advised. Then sufficient free space, kailangan malaki rin yung space mo kasi nga kapag tayo ay nagsisave ng mga output, medyo malaki din po itong napapasok ni STAAD, no? Okay, for the content of STAAD, interface lang naman yung i-discuss ko muna dito kasi all throughout dun sa pag-actual na, doon na natin yung isa-isahin yung ano na. So, ito yung content ng STAAD. Once na nag-open ka ng STAAD Pro, ito yung makikita mo. Pero alam ko ito ay lower version pa. May mga STAAD Pro Connect pa kasi. No? Ito ay STAAD Pro V8i, version 8i. So, sa first interface ng STAAD Pro, makikita mo yung project task, recent files, license configuration, help task. Si project task dito ko gagawa yung kung new project ba yung gagawin mo, or kung new projects ba, kung mag-open ka ng isang project, or mag-configure ng mga units with regards dun sa iyong calculations. Dun sa recent file naman, makikita mo dito kung ano yung mga previously opened files mo, ano, yung mga ginawa mo, makikita mo dyan sa recent. Dun sa license configuration, makikita mo kung license yung STAAD Pro. Magi-green yan, pero dyan sa nakikita nyo, walang green kasi alam nyo na hindi yan license, na naka-crack lang po yan. Pero sana nga, sabi ko ano nakaraan na video, this is a pilot, pilot curriculum pagdating dun sa at hindi na-anticipate ng school na mag-provide ng license software. Pero alam ko wino-workout na rin nila, no, and hoping that this year, next sem, magkaroon na ng license software din ng school namin. So, yun. Then, dito sa help task, makikita mo dyan kung pag may mga questions ka, queries, dyan mo makikita yung sagot, no, or possible tulong kung sakaling nahihirapan ka mag-operate ng iyong STAAD, no, pag nagka-problema. Then, ito naman, kapag in-open mo na yung STAAD mo, kapag gumawa ka na ng open project ka, nag-configure ka na ng mga units doon. So, ito yung mga workspace mo na workspace na layout interface. Dito makikita mo yung menu bar dyan. Sa taas, nandyan yung file, view. Yung parang sa MS Word din, may mga file view yan. Then, makikita mo yung toolbars. Doon sa toolbars naman, dyan yung mga commands, no, na pwede mong i-click na lang. Pero kung alam mo naman yung shortcut commands, pwede rin po yun. Then, page control, dito mo makikita kung ito ay beam, column, yung properties nung yung ginagawa. Then, main window or working space, dito ka gagawa mismo ng model mo, no? Then, data area, dito naman makikita yung data ng iyong mga ginawang models, no? So, as of now, yun pa lang muna yung ating kasi sa susunod na video, doon na tayo mag-actual discussion na mismo ng sa STAAD, no? Kung baga gagawa na tayo ng ganito. Wait lang. Ito. Kung baga mag-open na tayo ng ating STAAD, no? Para tuloy-tuloy po yung natin. For the next video na lang po siguro yon. But for now, thank you for watching this video, and I hope na kahit pa paano na-orient kayo at saka naliwanagan kung bakit maraming software for structural analysis ngayon na lumalabas. Kasi nga, sa laborious ng pag-design analysis, syempre kailangan din ng aid o tulong ng mga civil engineers at structural engineers para mapalesen yung time frame ng pag-design analysis. Tsaka para ma-lessen yung error kung sakali. Kasi kung manual manual calculations yung gagawin mo, prone sa error siya. Pero kung software, configuration lang kung sakali, no? Kung magka-error man, i-configure mo lang ulit yung ano mo, program, then check mo na ulit siya, no? So I hope na may naintindihan kayo kahit paano sa aking discussion pagdating din sa introduction na mga software na ginagamit for structural design analysis. Okay? So for bago ako mag-end, ang aking mga estudyante ay kailangan ninyong mag-comment sa comment section ng aking YouTube ng mga learnings ninyo, no? So siguro mga nasa 19 students kayo. So you need to comment what you have learned in this video, no? Para at least ay ma-monitor ko na kayo ay nanonood or nanonood ng aking video at willing kayong mag-observe ng mga knowledge na aking nire-record, no? So, yun lang. Thank you for watching.